I'm George Crump, founder and lead analyst at Storage Switzerland. We're an analyst firm, obviously focused on storage. We do a little bit, I don't know if you guys have heard of this flash stuff, but we're kind of big into that as well. It's my pleasure to introduce Nigel Alvarez, who is the Vice President of Marketing for the Flash Business Unit at Marvell Semiconductor. He's responsible for designing and driving new product solutions spanning edge to cloud data center environments. So join me in welcoming Nigel.
Thanks, George. Slides are not coming up. Oh, there we go. Well, thanks for attending here. I'm really excited. We have a lot going on right now with all the excitement. Yesterday, 4D NAND was announced. We had Toshiba becoming Kioxia. We have computational storage. So today, what I'm going to talk about is some of the innovations that Marvell is bringing to the table to drive the data economy and proliferate going forward. So if you look at the current market, you've had multiple growing waves of innovation and productivity growth. It started with the first wave in the 1980s, where you had the advent of the personal computer. So that obviously boosted up productivity and lots of innovation. New industries came about. Dell, as an example, was really formed around that first wave. Then you went into the second wave in the 1995 timeframe, where you had the internet era. We had companies like Netscape, AOL, Yahoo that emerged and really drove increased productivity with new business models that emerged, new ways of connecting with people and sharing data. And then we moved into the third wave in 2007 with the advent of the iPhone and smartphones. And this really drove another plethora of innovation as well as productivity gains and new businesses. New companies emerged significantly around this era with significant new businesses around connectivity of mobile data moving back and forth. Then you moved into 2011 era, which was the cloud era, where now if I started a company, I no longer needed to have my own infrastructure. I can actually go out to Amazon AWS and get my infrastructure served to me. So this actually lowered the cost of starting a business and started to enable new businesses to get off the ground. And we're still living through this era, but we're getting into the later innings now. After about 8 years, 9 years of AWS being around, you're starting to see more and more businesses now leverage the cloud to actually move to the last current era, which is the data era. And this is the era where you're seeing more and more data being generated. And this is going to create more business opportunities and business models, but also increase productivity. So this is a significant era that is going to drive changes. And the infrastructure must transform to proliferate this data era. And the reason for that is you're seeing unsustainable demand and growth velocity right now. And that means the infrastructure that we currently know needs to change and transform. And from that perspective, the scale and the growth of data is also driving the need to decentralize the cloud. So you can't move all your data up into the cloud and process it and move it back. You have latency limitations that needs to process the data closer to the data, right? As Tad mentioned, this computational storage is one of the current solutions going after that type of requirement. And then last but not least, which ties into computational storage, is the need to drive optimized architectures. So this is where you're starting to see the next speaker, Salil, is going to talk about accelerators using FPGAs. There's ASIC accelerators, offloads. So this is driving the need for more optimized architectures. Combine that with 5G and artificial intelligence, you're going to see an acceleration of the transformation. And there's going to be a significant opportunity for all of us in the room to capitalize on that new technology coming into play. Now, what is 5G? So 5G is the next evolution of the carrier networks, which really has come a long way from 1G analog. You remember those brick phones that people used to carry? So that was an analog-centric world. Then growing up in college timeframe for me, we actually started to move to a digital era where we had these SMS 9 keys where you'd text your friends and so on. So that was the early starting of digital communication with the 9 keypad. And then in the early 2000s, you moved to the data 3G. So 3G actually helped you move data and basic apps. And then 4G came in the 2010 timeframe to actually give you streaming and more bandwidth beyond the basic texting and SMS capabilities. Now 5G is a completely different story. 5G is actually going to connect everything. It has 100x the bandwidth capacity. It's going to be able to 400x faster than 4G. So response time is going to be faster than a camera flash. This is going to create significant connected devices that will actually go machine to machine. So you're actually going to have a new creation of business models around the 5G infrastructure. So this is more than just hype. It's actually going to connect the world and unlock tremendous opportunities for all of us here. Now, how will it disrupt? It's actually going to have low latency, right? So the real-time speed, I talked about it being less than 1 millisecond, while today's 4G networks are 200 milliseconds, while the human reaction is 300 milliseconds. So very significant cut in latency. Ultra-high bandwidth. You'll be able to stream over 400 8K movies at once. So you're looking at about 100x multiplier over 4G, which is today 20 megabits per second, moving to 20 gigabytes per second. And then from a connectivity perspective, density. Today, 4G is 1 million devices in a 500 square kilometer radius. 5G is 500x denser. So you can actually have 1 million devices in 1 square kilometer talking to each other and using the bandwidth. So this is significant disruption on the infrastructure and opportunity for all of us to capitalize with new business models around the data. So 5G combined with AI will power the data era. You'll have factory automation with a ton of machines communicating with each other and doing more and more sophisticated applications. You'll have connected transport and smart vehicles. So autonomous vehicles will be driven by this 5G era. And then you got industrial IoT and extreme mobile broadband. So the gaming experiences, as an example, will be significantly more powerful than what you have today. And that actually ties into the next one here. You'll have immersive experiences from a gaming perspective and other types of interactions with folks. So what's the impact on flash storage solutions? One, you're going to see new SSD protocol interfaces and form factors. You know, a lot of the folks over the last couple of days have talked about data center form factors. So you're definitely seeing that with EDSFF short, long. You got your U.2s, the M.2 traditional. You're going to also see what Jeremy presented yesterday, that new type of PCI Express form factor. Plus, you'll see some new M.2 2230s, which I'll talk about a little bit more, creating small form factors that can go into edge appliances, edge computing areas. It's a huge opportunity for the ecosystem here to capitalize. You'll have new architectures and business models, right? So there's the do-it-yourself, which is already happening in the data center. You're going to see that happening in more and more client and edge computing type of applications going forward. This will be like platform-managed flash, key-value flash, computational storage like Tad talked about earlier, Ethernet bunch of flash, which I introduced last year and I'll talk a little bit more today. You're going to have significant opportunities to innovate around these new architectures given the 5G and AI capabilities, right? I didn't put AI SSDs, but AI SSDs is something we're demonstrating in our booth, in the Marvell booth. So there's definitely new architectures that are emerging because of the data era started with 5G driving it. And then last but not least, tying back to the new architectures, you'll have optimized platform solutions. And this is where you'll see companies build architectures that are optimized either at the edge or in the data center or even in the home that are very optimized around the application they're trying to serve. Think of it, we have a ton of new data that's being created. You'll need new infrastructure and new architectures around that, and you'll see some folks move to optimize architectures and platform solutions. So 2 disruptive flash solutions for the data era I'm going to talk about today. One is NVMe over Fabric Ethernet SSDs. And today's discussion will be mainly focused around cloud, data center, disaggregated storage, and enterprise storage systems. In the future, we'll talk about this technology being used in other applications. But today's discussion will focus really around these 2 areas in the data center and the enterprises. And then I'm going to talk about DRAM-less MDOT 2230 PCIe Gen 4 SSDs. So this is a form factor play, but it's combined with the DRAM-less aspect and PCIe Gen 4. You combine all those together, and you start to have some pretty cool innovations you can do for the edge and the client. So let's get started with NVMe over Fabric Ethernet SSDs. So we introduced the concept last year, and really it was around the problem statement. If you look at today's disaggregated SSD storage platforms, they're really called JBOFs. You have a PCIe SSDs or NVMe SSDs behind a CPU, a NIC, and a ton of DRAM. So the bottleneck really becomes your NIC, which today, best case, you're getting a 100 gig NIC. Then you got your CPU and DRAM. Each SSD can do about 25 gigabits per second. So 4 of those SSDs saturates your front. So it's a significant bottleneck if you're trying to get performance out of that SSDs, that set of SSDs. Typically, that JBOF has 16 to 24 SSDs. So your bottleneck is significantly, like 75% of that storage you're not getting the performance out of. Combine that with the CPU power, the DRAM power, the costs that those CPUs and DRAM cost, significant TCO impact. So something has to change. And this is where the end-to-end NVMe over Fabric Ethernet bunch of flash that we announced last year changes the paradigm. You go end-to-end, point-to-point, no bottleneck, right? You go from the host right to the drive. Every drive's 25 gig goes through that switch. So you have complete scalability, complete optimization of the IOPS coming out of those drives. So the way we see data centers and enterprises looking at this today, what they love about it is every time they add the drive in, they're getting the performance of 25 gig. There's no bottleneck. 2, they don't like the legacy CPU power. This gets rid of the CPU power and the DRAM. I can't forget about the DRAM because that takes a lot of power and it's very costly, right? So those 2 key elements of cost savings from both a CapEx and OpEx perspective combined with the performance scalability, it offers customers significant TCO savings. Last year, Toshiba Memory and us showed greater than 65% TCO savings. So fast forward, last year we announced this and demonstrated with Toshiba, the industry's first NVMe or Fabric Ethernet SSD converter controller. That enabled you to take any NVMe drive and bring out Ethernet. And we did this with our partners Toshiba Memory. And we demonstrated 14 million IOPS in our EBOF last year. This year, we announced with our partners Toshiba, and Jeremy presented this yesterday, the industry's first in-form factor NVMe over Fabric Ethernet SSD. So now you no longer need that dongle or interposer. It's inside the drive, in the form factor, plug into the backplane. You got 25 gigs, you're scaling linearly. And this is being demonstrated both in Toshiba Memory's booth as well as our booth. 2, again, last year we had the interposer, the converter controller chip, and here you see our SSD controller. So it was a 2-chip solution to enable an Ethernet SSD. This year, we announced the industry's first native NVMe over Fabric Ethernet SSD controller. So completely single chip integrated NVMe over Fabric SSD controller that enables you to have a smaller footprint, easier to integrate, single chip solution. So this is, again, showing the progress we're making on trying to enable this market with significant progress from last year. You can see in our booth, and we're demonstrating this, this is a in-form factor 2.5-inch NVMe over fabric Ethernet SSD, so very clean, dual-ported. We're working with the ecosystem on the connector, so we're leveraging the 8639 with an Ethernet pinout. This one supports up to 8 terabytes of capacity, up to 700K IOPS. And again, this one too is live, being demonstrated at our booth. Next up, on the third architecture, last year we demonstrated with our native Ethernet switch family. So Marvell has Ethernet switches to enable this infrastructure. So we demonstrated this with our 1.8 terabit per second Prestera CX 84,000 family, or 8400 family. This year at Open Compute Summit, we announced the Prestera 8500 platform or product family. And this family actually integrates storage-aware flow engines. What does that mean? That means you're able to now dynamically track the flows through the network, really giving you visibility into the network resource usage. It also enables you to enforce policies on an initiator coming in or a target, so you're not actually have one person clogging the network. You can actually police it and monitor it and don't avoid deadlocks. And then you can actually limit the bandwidth of a given aggressor or a target. So significant gains to actually drive an Ethernet storage infrastructure from last year. So if you look from an architecture perspective, we have an end-to-end architecture. We have our ARM Thunder CPUs that are server class, 64-bit class, with our FastLink NICs. So those devices sit on the host side. Then we have our Ethernet bunch of flash. So the Prestera family in between, and then you got your Ethernet SSDs behind it. So this is, again, a very scalable, optimal solution for disaggregated storage in the data center and in the enterprise. And we're very excited about the market traction with customers on this. They're all engaged heavily with this. It's not a question, when we talk to them, they don't say it's a question of if, it's a question of when. It's really a question of when, because as you imagine, when you move to a new architecture in the enterprise or data center, they got to go through all the quals, all the corner cases. So that's the early innings we're in right now with customers. And you see the progression this year with our partners Toshiba, that now we're moving to the next phase of more integrated, optimized solutions. And hopefully next year we'll have more progress to share with all of you. So now let's talk about the next area of focus that we're enabling for this data era. This is the DRAM-less MDOT 2230, so it's a small form factor. And the other key disruptive with our friends at AMD is the PCIe Gen 4 transition, right? So PCIe Gen 4 enables you to not only get more bandwidth, but also consolidate the number of lanes, right? So less power in a system. So I'll talk about that in the next couple of slides. So let's talk first why MDOT 2230 for edge and client computing SSDs. So today, the majority of client and edge is using 2280s, right? So this is a typical 2280. Fast forward to a 2230, you see significant space savings, 62.5% savings to be exact. And from there, you actually are able to lower power. How are you able to lower power? Is by getting rid of the DRAM. So you're eliminating the DRAM to significantly lower the power at the SSD level, but also on the controller, you no longer need to have DRAM interfaces running traffic back and forth. So you get rid of that, you save power at the drive level. And these drives typically today are 6 to 7 watts on the 2280. The 2230 is going to be sub 5 watts. So you're seeing the significant 30% plus savings on power. Next up, you can get capacities up to 1 terabyte on a single side. And I'll talk to you about how this is all happening, right? Because everyone's scratching their head, hey, there's 4 NANDs, now you have 1 NAND, how are you going to do that, right? And then 2, or the last point here, comparable high sequential and random performance. Again, another head scratcher. How are you going to do that? Less NAND. How does this all come together? More performance, high capacity. So let's talk about that. How? So 3 key NAND component trends. First, the NAND die capacity from 2015 to 2019 is up 4x, right? It used to be 128 gigabit per die. Now you're up to 512. So 4x the capacity in that footprint. And as our good friends SK Hynix said, that's skyrocketing even more with 4D technology, right? So Toshiba, I think, said 1 terabit by the end of this year. So you see the significant die scaling. 2 is the NAND interface speed, right? In 2015, it was 533 megatransfers per second. This year, Micron is showing 1,200 megatransfers per second. So you're up 2.25, and I can tell you the NAND makers are innovating on this as well. You'll see faster speeds. 3 is if you look at a NAND die, the planes that it was supporting in the past was 1. Now you're up to 4. So you're getting a 4x gain on this. So the result is you have reduced NAND dies per equivalent SSD. So 75% reduction on the NAND dies without compromising performance because you have all those other factors coming in, the NAND interface, and you have your planes going up. So combine all that, mainstream 1 terabyte SSDs will no longer require larger, higher power 8-channel SSD controllers. So significant disruption in the marketplace, right? No longer needing the 8-channel, you can shrink your SSD controller, which obviously will lower power, hopefully gives cost savings, and get rid of the DRAM, right? So you're seeing a huge potential change that's going to emerge over the next 24 months as the technology gets ramped up. So what we're doing at Marvell, we introduced last Thursday the industry's first 12 nanometer PCIe Gen 4 DRAMless product family. These 2 devices for the DRAMless side are PCIe Gen 4x4 and PCIe Gen 4x2. And now the reason why you have 2 SKUs, there's certain applications where you really need to worry about power, so why use more PCIe lanes, right? Focus on just the number of lanes you need to get the bandwidth out of the NAND. So we have 4 NAND channels running at 1,200 megatransfers per second, supporting the latest and greatest NAND. This consumes less than 2 watts, and it provides performance up to 3.9 gigabytes per second and up to 500K IOPS from a random perspective. And then, last but not least, again, you get the power savings, which everyone wants, which helps your thermal, puts it in smaller form factors. And then you get the footprint to fit on that 2230 and help the thermal dissipation. Because power is what everyone talks about, but the thermal challenge is as significant, if not more, than the power. You know, I was talking to a couple of folks last night, and they were telling me the number of dollars they're putting on the thermal side of their platforms is outrageous. And this is an area that I think as an industry, we got to innovate on shrinking the power for these devices to increase the thermal efficiencies. And that's why you'll see more and more new form factors, because those are ways how you can actually get more optimal thermal dissipation. So to summarize, 5G and AI will proliferate the data era and require new flash solutions. So this 5G era is in the first inning of the game, right? You'll start to see deployments towards the end of the year. Marvell is working very closely, publicly announced with Samsung infrastructure 5G deployments towards the end of this year. So you'll start to see 5G really being deployed in North America as well as in Asia. And that will help start to drive a lot of new architectures. And then you bring in the AI element, which I think, just to stress here, AI has 2 sides of the coin, right? There's the training, which will happen in the cloud, right? No one's going to bring training to the edge. It's too much data. You need as much data to train. The inference is actually going to be at the edge. So you'll have more and more inference engines at the edge to take advantage of the training that's happening in the cloud. And that's where the flash solutions come into play, is complementing the AI inference engines. EBOF, as I mentioned earlier, is the optimal flash storage for disaggregation architectures. And I think what you're seeing right now is, given the scaling of performance of these new SSDs, you need to re-architect those architectures. You can't use a NIC, smart NIC, or a CPU plus NIC, because that becomes a bottleneck, a performance bottleneck. And then the other factor is a power hog, right? It's going to be too much power you're dissipating, and you're not getting the performance. So EBOF is the optimal architecture for that. Ethernet SSDs are here today, right? So that's a big accomplishment by Toshiba and ourselves to actually get Ethernet SSDs out there in form factor. I can't stress, having an in form factor SSD just makes it easier to deploy, and we expect other SSD makers to have Ethernet SSDs over the coming months. The DRAM-less MDOT 2230 combined with PCIe Gen 4 will become an optimal solution for edge and client computing. This, again, is being driven by the form factor combined with the performance. You get those two things, why wouldn't you go to the small form factor? Think about it. What's our number one issue as a laptop user, as an example? Battery power. It drives me crazy. I'm on a plane, within like an hour, I need a plug to put it in. So guess what? If I use the 2230, less power, and I give my OEM more space to put battery type of technologies, my life of the client product will be longer, battery life. So that's just one example on the client PC side. And on the edge, think about it. There's not going to be significant power for all these edge devices, where power becomes even more critical, and space, right? So again, the 2230 DRAM-less solution is going to become mainstream in the next 2 years. And I'm proud of the Marvell team of producing the industry's first 12 nanometer PCIe Gen 4. Now, 12 nanometer, just to stress, gives us a significant power savings. Moving from 28 nanometer to 12 nanometers, you see a significant cost savings. You see, obviously, die size shrink as well, and you're able to add more SRAM to give you the DRAM-less performance. So that's another key thing. Those are available now. They're in our booth demonstrating for those that would like to check it out. So to summarize, a lot of disruption, lots of opportunity, and I'm excited about the technologies we introduced, and I'd encourage you all to come visit the Marvell booth, number 511, to see the EBOFs in action, the PCIe Gen 4 SSDs, as well as some AI demos and centralized automotive storage. That's all in our suite, so please come. And then check out the Toshiba Memory Suite booth that has the industry's first 2.5-inch Ethernet SSD. Thank you very much.